SpaceX's Starlink satellites are affecting weather predictions is a debate that raises scientific, technological, and atmospheric concerns about the growing impact of satellite megaconstellations on Earth's forecasting capabilities. Starlink, a project by SpaceX, aims to provide global high-speed internet coverage using thousands of low Earth orbit (LEO) satellites. While the system offers faster internet access, especially in remote regions, scientists have raised concerns about its unintended consequences for weather forecasting. Meteorologists rely on satellite-based weather sensors, radio signals, and remote sensing technology to monitor atmospheric conditions and predict severe weather. Starlink's massive satellite network operates in radio frequency bands that overlap with frequencies used for weather data transmission and Earth observation. Scientists warn that Starlink satellites could interfere with weather prediction models by distorting microwave signals used to measure atmospheric moisture. Microwave sensors on weather satellites collect critical data about humidity, temperature, and cloud formation, which are essential for accurate forecasts. Starlink's radio emissions may introduce signal noise, making it harder for meteorologists to detect subtle changes in the atmosphere. Disruptions in weather data transmission could impact hurricane tracking, storm warnings, and climate monitoring, reducing forecasting accuracy. Meteorologists fear that weaker data quality could lead to shorter warning times for extreme weather events such as hurricanes, tornadoes, and blizzards. One major concern is that Starlink satellites reflect signals from existing weather satellites, creating radio interference that affects data collection. Astronomers have already raised concerns about Starlink's impact on ground-based telescopes, as satellite reflections create streaks in observational images. Some scientists argue that Starlink's interference with weather satellites could weaken climate change research, making it harder to track global temperature shifts. NASA and NOAA rely on precise satellite measurements of atmospheric water vapor, which could be distorted by high-frequency Starlink transmissions. Meteorologists argue that reduced data quality could impact weather prediction models, making them less reliable for long-term climate forecasting. If Starlink interference worsens, it could increase errors in rainfall predictions, flood warnings, and agricultural planning. Climate scientists depend on radio frequencies in the 23.8 GHz range, but Starlink operates in similar bands, raising concerns about unintended overlaps. The Federal Communications Commission, FCC, has approved thousands of additional Starlink satellites, increasing the potential for widespread interference with weather models. SpaceX has stated that it is working to minimize interference, but some researchers believe that the sheer number of satellites will still pose risks. As Starlink expands, the potential for signal congestion in low Earth orbit increases, affecting multiple scientific disciplines beyond meteorology. Some experts argue that regulations should require satellite companies to coordinate with weather agencies to prevent interference with critical climate data. If Starlink and similar satellite projects continue without oversight, weather prediction accuracy could decline globally, affecting disaster preparedness. Satellite networks like Starlink also pose challenges for military weather monitoring and space-based reconnaissance systems, which rely on clear radio signals. One proposed solution is to develop new weather satellites with stronger resistance to signal interference, but this would require additional government funding. Another approach is to restrict Starlink's operating frequencies, ensuring they do not overlap with critical weather monitoring bands. SpaceX has defended Starlink by stating that it is providing an essential service, global internet access, that outweighs potential scientific drawbacks. Supporters argue that better internet connectivity could improve disaster response efforts, allowing emergency teams to coordinate during extreme weather events. However, critics counter that accurate weather forecasting is essential for preventing disasters in the first place, making Starlink's interference a serious concern. Some meteorologists believe that AI-driven correction models could reduce the impact of interference, but this would require advanced data processing techniques. The European Space Agency, ESA, and other international organizations have expressed concerns about how satellite megaconstellations could affect scientific research. In 2020, a group of scientists warned that large-scale satellite deployments could permanently alter Earth's ability to monitor climate patterns. Starlink is not the only concern, as other private companies, including Amazon's Kuiper and OneWeb, are planning similar satellite networks. As more companies launch megaconstellations, the risks of radio interference, space debris, and atmospheric disruptions continue to grow. Some researchers argue that a global regulatory framework is needed to balance commercial satellite expansion with scientific priorities. If left unchecked, interference from Starlink satellites could increase forecasting errors, leading to economic losses in agriculture, aviation, and disaster response. Meteorologists emphasize that even a small drop in forecast accuracy could result in billions of dollars in damage from storms, droughts, and extreme weather events. Some nations are considering developing their own protected weather monitoring satellite systems, ensuring that scientific data is not compromised. Without clear regulations, private space companies may prioritize commercial interests over environmental and scientific concerns, leading to conflicts with government agencies. If Starlink's interference worsens, future space missions might struggle with precise atmospheric modeling, affecting Mars colonization and interplanetary weather predictions. Ultimately, the debate is not just about internet access versus weather prediction, but whether commercial satellite projects should be subject to stricter scientific oversight. The real question is how to balance technological progress with protecting Earth's ability to predict and respond to climate-related disasters.